should be a learning forum for me also. So, and thanks myself, Karthikeyan Asokan from Coimbatore, basically. So, working for an MNC here. So, basically, I finished my production engineering in 2006, and for all these days, I'm working as a part of design and development of new product development design teams in various companies. Like first started with Lakshmi Machine Works, and then uh, uh, transferred to Quattro Engineering. It is one of the uh, leading software and tech companies here in Coimbatore, which is associated with LMW. And I'm the first person who started the new product design team there at Quattro Engineering, and then transferred my job to Bosch here in Coimbatore. So this is my career, and uh, for TRIZ, actually, it is an accidental introduction for me to TRIZ. When I was working with problem-solving techniques, mostly here in our company, we promote 8D, and then some other problem-solving techniques. But okay, those are structural problem-solving techniques, but it is not a very what is it interacting tool which will provoke our innovative thought process or creative thinking. So the the problem solving technique should be like combined way of creative thinking and also a structural way. So in that way, when I had a search, I finally found that there is a tool called TRIZ. It is about 4 or 5 years back, and whenever I searched for learning materials for TRIZ, I found this basic materials like the contradiction matrix, all those things. It is very limited material which is available open source. But uh, when it was like I'm deep diving into the topic, I found like it is wow factor was there, because uh, how come a tool can provide a structural way of uh, thinking, guidance for, and also it will not uh, take us in a uh, analytical way of thinking also, I would say. It will not restrict our thinking. TRIZ will not restrict, but it will give you a way. That is what I understood with the tool, and then deep dived into it. There is a saying like if you are a student, if you start being a good student, a good teacher will available in front of you. There is a good saying in Tamil. So it happened eventually that when I started searching for TRIZ, I got a mentor from here itself in Bosch, Germany. His name is Oliver, Gerund Oliver. He is a TRIZ L4 certified person, and the challenging part is he knows only German. I know only English. But meanwhile, when we are discussing and all those things, he started learning English, and all the materials whichever he have, everything is in German. That is the good part actually, because when I started to translate everything into English, what happened in the process, I started understanding the tool in a better way. So that is also one of the advantage which I got. So for every struggle is like a forum for us to learn better and make ourselves better. So that is what happened. So first I start with an icebreaker. Hope you all will be having uh, uh, sitting in front of a computer, or you will be having a paper or pen. Just 1 minute we will take. I will give you an icebreaker like, uh, can you please take a pen and paper, or you can open the Power MS Paint in your uh, computer or laptop. And please give a thumbs up if you have opened it or taken the paper and pen. The response we can get by thumbs up, right? Sandeep here, or how it works, the tool? Yeah, thumbs up is there now. Yeah, correct. Yeah, hope you all have taken or opened the Power MS Paint, or you have taken the paper and pen. Okay, just you can start drawing a natural scenario. It's a early morning, just a simple script, not a uh, painting kind of thing. A simple line drawing is enough. It's a early morning, and you are seeing the sun or like that. It's a early morning drawing. You should draw. That's it. It's a early morning. I'll give you a minute, or 30 seconds is enough. Yeah, 30 seconds. So this exercise I have did in n number of forums, say for about 30, 40 forums I have did in a crowd of about 200 people also I have did, and the results are same. I'd say. Okay. So Sandeep, can you open the picture which I have sent to you?
Yeah, just a sec.
Yeah.
Even I tried this several times and I know what is the result.
Yeah. Yeah. Yeah.
It's
Yeah.
interesting.
Yeah. It's interesting actually.
Yes.
No, the picture which I have shared, via mail, I have sent you. Picture.
You sent one more thing? Okay.
Yeah. Yeah.
Sorry, I just downloaded only one.
Yeah.
Just give me a sec.
Yes.
Oh yeah.
Yeah. How many of you have done some similar kind of thing? Two mountains and sun and some birds around it. Okay. So this is what. So there is nothing magic behind this. This is the scenario what we are having as a inertia in our mind. So thinking block or inertia, that is what we are having, because we all studied the same book, we all studied the same material, analytical way only we will be thinking. So we all will be having the similar kind of picture. Somebody will be having some river or something, but
Yeah,
two
that is
mountains or
there.
similar.
One river I added in it.
Yeah,
Maybe
that's what.
maybe a hut.
Yes, that's correct. Hut.
Yeah, yeah. So
And
this is the wonder actually. This is not wonder, but this is the scenario that the mental inertia that we have. So for that only this tool will help actually. A structured way of innovative tool which we need to have, so that we will be not driven by this inertia. To avoid this inertia, so a lot of times there would be at the initial point of ideations or something. No, what will happen? We will be thinking that for some some problem, some solution we would be arrived, but we will be thinking that this is the unique solution that I got it. But what happens when we go into the forum? Some of the people also will be having the same kind of solutions. So that is the inertia we have. So we all will be thinking in the same manner. So to come out of this inertia, definitely and structured way of tool is needed. The right tool is called TRIZ. Okay. So Sandeep, you can share the
Yeah,
screen.
I'll do that. I'll
Yeah,
toggle to that.
yeah, yeah. Okay. So today,
Yes, you can go ahead.
yeah, yeah, today I will be covering the golden circle part of TRIZ. I'll be approaching the TRIZ
It is
like
visible, no?
why. Yeah, it is visible. So I'll be approaching, right, the golden circle. So circle starts with why. So why is the first question? What should we need to know in any of the things that we wanted to learn? So why trust is needed? Because in the traditional way of brainstorming, there will be lot of solutions. Okay, for a problem there will be lot of solutions, and distractions also will be there. Like which is the best solution, we will not be knowing, and how to come to a conclusion that this is the best solution that I have. So for all those things, our energy will be wasted, because to find out what we will be doing is searching the key. Uh, the right way of searching the lost key is where we lost it. But what we will be doing is we will be searching in some other place. So for that, a structured uh, a path and a constrained path it will give, but it will not constrain us our thinking, but a direction it will give. So that for that only TRIZ is used. And sometimes what happens, you can see this cycle which is running here. The solution will be hidden behind us. It will be very near to us, and already it is implemented in the same system or same subsystem or super system. But we will not be knowing whether we will not be knowing that is the best solution that can be fitted into the same place. So in order to identify the nearest resources and the solution which is hidden behind those resources, TRIZ will be helping us. So why TRIZ? TRIZ is a method which will give a constrained way of path and fast approach towards the solution, and also to find out the hidden solution within it, within the system or within the super system, like that. Okay. So I think in a nutshell, why part is covered, and I will move to the what part. Yeah, you can move. So what is TRIZ? You can zoom in a little bit. So you all be already knowing that TRIZ is structured by Altshuler in 1946. He framed with some minimum number of principles, but now it is a matured stage. So TRIZ is structured with three pillars. One is many inventions will be following only limited number of inventive principles. That is what Altshuler has founded. How he founded? He founded with, you can zoom. He founded by studying uh, about 50,000 patents or inventions already, which is available in the market. And he came up with a conclusion that every invention will be following some set of patterns. What are those patterns? He has structured it. So many inventions will be facing only limited number of inventive principles. Those principles only he has distilled from those 50,000 patents. And then strong inventions overcome contradictions. Say, for example, a simple example I can give you. If a car needs to be uh, uh, it needs to have more mileage, then it needs to be less weight. Okay, but if it is less weight, then the strength will not be there. So this is the contradiction. The strength point of view should also be uh, um, uh, like it should also be satisfied, and also this mileage should also be increased. Where is that common point? That common point should be that contradiction should be solved, so that while solving that contradiction, a new solution will come. So every strong inventions behind there will be a contradiction. This is the second pillar. And the third pillar is technical developments follow a recurring trends. So, for example, if you take the mobile industry, it is a like we started with speaking with the wire and then on a small tumbler or something, okay, a cup. So that is the starting of communication between the distance. So after that, now we have the mobile phone with the touch screen. So this evaluation will follow a trend. That trend also he has recorded. When he has recorded is 1946. That is the wonder actually. So when we try to understand this three pillars, then we can enormously we can invent a lot of things, innovate a lot of things. Okay, so these are the basic pillars, and what TRIZ is based upon, what TRIZ is built on to it is these three pillars. Okay. Okay. Then where we should use TRIZ? Okay, this is the question which I have when we give an introduction session or when we try to speak about TRIZ. People will be asking where we can use this, because every problem solving technique can be used in uh, some areas where it can be more efficient. For example, 8D. 8D can be used only in the areas where some changes is implemented in the existing system. So like that, where TRIZ can be used. TRIZ can be used only in these green areas. You can see any level of innovativeness will be in 5 levels. One is first, the top level is breakthrough. Okay, breakthrough means, for example, if you ask who invented light, we will say Edison. It is not, he has not invented light actually, he has innovated light. Okay, who has invented light means the man who started seeing the fire. When the two stones were rubbed and a fire has come, no, he is the inventor. So that is the breakthrough. In that breakthrough, whether TRIZ can be used? No. Whether it can be used in any innovation? Yes. All the innovations followed up a new concept. For example, as I said, the same example I will take. A man has found that while rubbing two stones, a fire has come. When he started thinking like how to withstand this, how to make the life of the fire more, then he started with some straws which were near him, and he started flaming it. That is the next innovation. So he founded some problem like that fire is not getting its stand. So he wanted to make the fire's life higher. So he introduced one more medium, a straw. Okay. Then what happened? That is also the life is very minimum. Then someone has come up with this carbon filaments. Then what is the success of Edison is he come up with a filament with which has higher life. So this new concept generation can be possible via TRIZ. Okay. Then major improvements. That is 18% of innovations will be in major improvements. Like there will be a problem and that problem needs to be eradicated. For example, some cost has to be reduced. For example, some new failures needs to be overcome. If I would say, in automobile industry, the common rail system is one of the major improvement, wherein the efficiency is improved with the single common rail system, which Bosch has. So that is one of the major improvement area. Okay, for that TRIZ can be used. Then minor improvement areas like which has 43%, which lies in like small improvements which will solve small problems. That area also TRIZ can be used and faster solution can be arrived. In which area any tool cannot be needed is the obvious solution, because obvious solutions will be it is eventual. It will arrive anyway. So no tool is needed. So TRIZ is also not needed. So where TRIZ can be used, it is not on the breakthrough. Any new chemicals that needs to be introduced, whether TRIZ can be used, no. But two chemicals, some solution should be arrived in order to arrive at a new chemical formulation. This can be used. If some software, for example, we have in software like some new method or new plugin should be created. It's a new concept of solving a major problem, then TRIZ can be used. So these are the areas where TRIZ can be used. Okay. So if that is clear, you can give a thumbs up so that we can move further, because we started with why and what is TRIZ and where it can be used. So if this is clear, then the next one is the methods and the principles that we can follow. How part is the next. So in the golden circle, last circle is the how part. So if you are okay, then we can move to, you can give a thumbs up so that we can move into the principles. Yeah.
What does that percentage indicate for different categories which you've shown?
A percentage. Okay. Percentages, again, if you take the major innovations that is happened, these are the percentages that is lying. Like new concept, new breakthrough will be 1% only.
Okay, out like if some innovations are happening in that breakthrough is 1%, and
Yeah, breakthrough will be invention always. So that invention will be only one percentage.
okay, that
Using
doesn't
that invention, yeah.
okay, that doesn't
Tell me.
relate to TRIZ in any
Yeah,
means.
it doesn't relate to trust. It's a
Okay,
common. So
okay,
where the trust can be used, that is what this pyramid is speaking
okay,
about.
understood. Yeah.
Okay, in which area our tool can be used? Trust will help in which area of innovation and inventions? Okay, no?
Yes, yes.
Yeah. Okay. So now we have finally arrived at to the how part. So how part is like what this will basically do is we will be having for any problem or anything, there will be an ideal part. For example, you can try it today if you are married and if you have kids at home or your siblings or somebody. You can go and ask, can you fly? Or how you can fly? Just he will tell that I should have a black scarf in back of my backside and I can fly like a Superman. So that is the ideal thing. Okay. If not, another answer will come like, if I have wings like bird, then we can fly. This is the second answer that we can get from a small kid. That is the idleness. So ideal solution doesn't think about how part. Okay. So it will not. It is very like um, it will be not realistic, but it will give us a picture like uh, how an ideal solution should be. Okay, but it is not realistic. Then what is actually will be there is the system what we have. Okay, so what this will do is try to meet both this point in a middle point where a realistic solution can be arrived with the help of whatever the uh, technologies which we have as of now. Okay, so when we talk about flying a rocket, cryogenic engine, before cryogenic engine, it is only the explosive what we have to launch a rocket. Okay. So after cryogenic engine, we will not think of the explosives. So this is whatever the technology which we have, or the system which we have, or the super systems which we have, that has the limitation of the solution, but the ideal solution will be different. It is like idle. It cannot meet the current system cannot meet that idleness. So in order to close the gap between these things is the challenging part where the optimal solution will be there. For that, TRIZ will help us very, very good way and reach us to a optimal solution in a faster way. Okay. Am I clear about the examples or still some, because this is very, very important area. Yeah. Okay. Thank you. And for see, if you think about the ideality, what is the ideality is we will be having enough benefits, but there are pulling things like the cost and then the harmness. Okay, we have to reduce the cost and harmness and increase the benefit. For that, TRIZ will be helpful. TRIZ is a key concept in TRIZ to assess the system goodness. Only the current system what we have or the technology what we have, and the goodness only we will extract and we will try to meet the ideal solution. So we will try to meet the gap or match the gap or reduce the gap as fast as we can, and the TRIZ will help us. Okay, so we can move next. How the systematic method will help. Actually, TRIZ is having a deck of tools that I will introduce later. So this deck of tools will first start with the ideality, and then what the current system will we will go with the benefits. What is the current system benefits, and then we will analyze with the functions of that. We can rank the functions, we can identify what is the harmful function, what is not needed a function, what are supportive functions, what are less used functions, and then we will go to the resources. So we will match the benefits via function to the resource. So what are the existing resources that are unutilized, whether we can match those functions to that resources, or can we reduce some resources and utilize and make the functions run without some resources. All those studies can be done and the ideal solutions can be reached very easily. So it is like we have the need, what I needed, and there is an ideal solution. So in order to go from the need to the ideal solution, this path will help. So the benefits, and then we will talk about study the functions. What are the needed functions that that will used to satisfy my needs, or the actual work that needs to be done, and then we will study about the resources, and the resources we will utilize those resources to make that functions to run. That's it. So every time what we will be doing is we will be concentrating only on the functions of each and every. The functions should be satisfied. That's it. Without resources also the function is, if it is satisfied, that is well and good. That is the ideality actually. So this is where we will be working, and we can move further. So this is the how part actually, how the TRIZ is working. Then it will follow some principle. We will go to the principles as fast as we can. And yeah. So first principle, yeah. The first principle is all the problems have their answer. Okay, and the answers will be hidden, as I said before. How it is hidden? As a solution in some other way. That's it. So what we will be doing, we will make our problem uh, to a common, we will convert our problem to a common problem, and that universal problem will have a universal solution. That universal solution we will be trying to fit in within our system. That's it. So this prism of TRIZ will direct us and diverge us to think like we will be like digesting our problem, and while digesting that problem, we will be uh, uh, arriving at different universal problems, and that universal problems we will be having universal solutions. That universal solutions will be having we will be trying to fit into our system. That's it. So the second principle will be like, as I said before, there is a contradiction. So for the two parameters, what we'll be trying to do is we will try to converge those things into the a goodness. So two parameters should get satisfied, and it will be meeting at a needed solution point. Okay. So then principle 3 is, principle 3 is all the contradiction, whichever we have arrived at some contradictions, all the contradiction will have some technical solutions and also physical contradictions. Okay. What are technical contradiction? There were already 39 design features, and those design features will follow technical contradictions. And then physical contradiction will have separation by time, space, conditions, and scale. And we have to identify these physical contradiction to arrive at to find out the suitable solutions. We have the catalog. Then principle number 4 is, principle number 4 is if we are arrived at the contradictions, then there is a matrix, ready-made matrix, which is available and created by Altshuler. And nowadays it is revised, and the numbers also got increased. Okay. So now on those catalog, we can arrive at a common point, and a ready reckoner solution will be available, which we can try to fit into our system. So this is the fourth principle. And then fifth principle is TRIZ. TRIZ has, as I said before, we should concentrate on the functions of the system. Okay, all the functions have values. Each and every function have values. Like we can rank it, or whether it can be classified also, like whether that function is harmful, whether that function is less used, whether that function is more used. All those things can be classified by TRIZ. Okay, this helps us to classify those things, and we can also have, provide value for the functions, and we can just rank the values, and then we can decide whether those functions can be used or not. This is the fifth principle. And sixth would be like TRIZ has deck of tools, and those deck of tools can be we should be knowing like what are the tools should be used for particular problem statement. For example, if we are doing some value engineering, then we should go for value analysis and trimming process. If we are doing some simple inventions, or sorry, innovations, then we should know how to uh, use contradictions. Like that, TRIZ has deck of tools. So that those tech of tools we have to we should know how to choose those tech of tools and use it. So this is the sixth principle. So in nutshell, these are the things that basically TRIZ and what and how it is used. And if in our case, like I have personally worked with about now 6 problem statements we have worked, and about 4 invention reports has been filed within this 3 years, and all were like business cases. All the invention reports which we submitted were like it is behind the it comes with business case, and it provides some cost saving, good cost saving in our project, or it is like a good revenue that is generated. Okay, so and in if I take in the software projects, there is a myth like as Altshuler has formulated everything in a mechanical way. This can be used only in mechanical. That is the myth what we have. But for sure, it is not like TRIZ can be used in personal life also to solve any problem. And now we are in the phase, like we are also in the incubation phase. We have taken 2-3 problem statements in software, and we are trying to implement in software topics. So in next connect, I can show you some seeds on those areas also. And definitely thanks for this opportunity, and open for questions.
Hello,
Hope
am I
Thank you,
audible?
Dr. Asokan. Yes. Yes, yes, please
Yeah,
go
hope
ahead.
hope your time is invested now. It is not
yeah.
wasted.
First of all, thank you very much. It's a wonderful session and very crisp and clear. You explained this all principle in a quick manner, I meant to say. I have one question. When you talked about the value engineering, value analysis, and you talked about the cost saving, I got one question in my mind regarding I know that there is a mechanical system where we identified some solution where there is a recurring cost and we will get saving year over year. How can we do savings in software? Because once we have released, it is done. We are not doing any recurring every day, right? For the same thing as a mechanical product. So how can we save the cost year over year in software through this kind of implementing this kind of systems?
Actually, this is like a great question which we also have, and we are still working on it. Actually, maybe in the next connect, I can definitely give you some use cases on this area. And again, we see in a nutshell, the basic uh, uh, what is it? The pillar of TRIZ is work on the functions. Okay,
Yep.
so definitely there will be some energy wasted in any areas if you take. So that the energy wasted should be identified via this structured way. That is the principle, basic principle, and we should use this structure. This trimming process will definitely help. You go with just we are starting with function analysis now. So you start with the function analysis, then go for rating the functions, then you can get the solution. I think so. Definitely, I can give you an use case in the next connect. Not now.
Okay.
I'm not having the use case now, but we
Thanks.
are driving in this area only. Like we are
Okay.
working on the functions, then we are trying to rate those functions and then making it. Yeah.
Okay. Thanks for answer. Thanks.
Yeah.
If I have
Uh,
to add to this, basically, the software industry is more about project management, and Chris is very good in managing the things also. And as
Yes.
rightly mentioned by him, that trimming, clubbing two things, segmentation. So what we
Yes.
want nowadays is like a minimum click should be there, and we should get the maximum output from that. So for this, there is a requirement of innovation, and we are already working on certain things on this parameter as well. But some of the case studies are not shareable. That is the limitation on the
Yes. Yes.
like platform like this. So that is why he's not able to share it. Yes, ma'am, you were asking something?
yeah, just to correct my understanding. So you explain these principles. So is it like that we have this 40 inventive principles, right, in TRIZ?
Yes. Yes.
So that is coming. I mean, that is different from these broad level principles. Is it like that, or
Come again. I'm not getting your
so we have this
question.
40 principles in TRIZ, I guess. They are
Yes,
providing
yes.
some
That is the
40.
principle number
Uh,
3, which I have given here. No, principle
Right.
number
So
3 is
base,
coming.
type of contradictions. So is it like
Yes.
when we want a solution, so these principles to be applied, all these principles to be applied in it, or particularly we have to select this principle according to our case, right?
Actually, according to our case, we have to select it. That is
Ah,
where this contradiction matrix will be supporting you. Actually,
okay. And can
yeah.
we
But
conclude?
but the one of the uh, uh, what I would say, suggestion or a suggestion from my mentor is, okay, if you are limited with the time, then go with this matrix. But if you are not limited with time, you go through all the 40 principles. That is what he has suggested us. So
Okay.
it is, yeah, it is better always to, because that is what the solution may be disguised. We will not be knowing. This is a guideline. This matrix is a guideline actually. So if you are limited with the time, directly go with this principle, guided principles. If not, if you are having enough time to work it out, you block the calendar for a week, go through all the 40 principles.
Okay. Okay. So can we like conclude the understanding like mostly TRIZ we are using wherever we are having contradictions?
No, it is not like that. It is the basic principle where all the innovations will be lying in a contradiction. It is one of the tool. Contradiction matrix and arriving a contradiction and contradiction matrix is one of the tool. But there were other tools which TRIZ is having in the deck, where in some of the areas, this contradiction itself we will not be touching actually. Directly we will be going to the solutions. Like we can do RCA plus, root cause analysis plus, or we can go with the function analysis and directly go with the trimming process. Like that we can go. But this is basic. Like this is basic, and the contradictions, if we touch, it will be well and good for any problem solving.
Okay. Okay. Thank you.
Ma'am, just for the clarity, there are 39 engineering parameters and there are 40 inventive principles, solutions which are made by Altshuler. And as you asked about this contradiction, the definition of an inventive problem. See, we have a problem to solve, but are we solving the right problem? How to identify it? So one of its measure is that whether it is having some sharp contradiction or not. Because if there is certain like in the beginning he has told, if you have a car, you can have a good mileage, but at the same time, what are the other parameters which are deteriorating along with this? So how we can ensure that both of them are improved? This is an inventive problem, right? And once you define this, you have to have a very sharp contradiction, and then this is a right problem, one of the definitions of the right problem given by Altshuler, and this is the way in which we have to go. Secondly, quickly, I would like to tell that just having a contradiction matrix is not enough. How to think further on that? Because he has just given some guidelines, but how to follow these guidelines meticulously and quickly how to reach out to the solution. So good you have asked this question. We'll try to have more details on this in some future TRIZtalks. Thank you. I hope within the given time we could answer your question, but definitely stay in touch. You can always contact and I'll type it in the message also, or you have info@trizasia.com and we'll be able to solve all your queries. Dr.
Yeah.
Asokan, please continue.
Yeah, rightly said. Something. Yeah, anything further questions?
Dear participants, you can ask other questions also related to anything, whatever TRIZ is like, or how Dr. Asokan has implemented it, how he has already shared how he got in touch with it. And of course, there may be some questions which may not be popped up as of date. So if you have any question, you can just send it to us through info@trizasia.com and we'll pass it on to Dr. Asokan, and on his sure that you will get the solution, apt solution from him.
So I have one question
Go
for
ahead,
Dr.
go ahead.
Asokan, and maybe a little different than the really technical. I meant to say he mentioned regarding when he is in Germany in Bosch. So during the transition, so he learned a lot. So just an curiosity of mine. So do you really learn all German language, Dr. Asokan, till today, and you can understand and read the German principles in German documentation?
Somewhat, it is not so easy. Actually, the German words are very long. It's very long, and some basics only have learned. Of course, Google Translator is supporting. Yeah,
Thanks for answering. I
yeah,
understand because that's what I meant to say. If you get some problem statement or the curiosity, it takes and brought up into that area and then try to create more things.
yeah,
Thanks.
yeah, yeah, yeah. No, when we start reading, no, like some of the patents which are again translated also, sometimes what happens, it is not full-fledgedly translated, full inventions are not translated at that time. It is better to read those IRs or patents in the original languages. So in that way, every day is learning for me also.
That's very true. Actually, most of the books written by Altshuler were in Russian, and
Yes,
translation
yes.
from Russian to English, it has lost its crux at certain
Yeah,
times.
yeah, yeah.
So now Matri's official is taking some initiative, and they are getting these translation done by the experts. And very soon we'll be getting these publications into the market.
Yes, yes.
Thanks. And I think we get another information. Something is going to get soon, which is more in detail.
And just to continue with your question, Chandra, as we say that this is a world wherein we have to know all the languages, or we should be able to decipher all the languages. So similarly is the TRIZ. TRIZ does not have any domain. It is not limited to mechanical, chemical, electrical, pharmaceutical. You name it and you have a solution of TRIZ from that. But only thing is that we should be able to put those things into those formulations and that patterns and that contradiction metrics and other tools.
Thanks for clarity. Thank you.
So we are reaching the time as well. If any quick questions are there, we can just take a few. As I mentioned, you can just pose these questions and we'll get the queries. And with this, we have come to the end of today's TRIZ chapter. And I take this opportunity to thank Dr. Asokan to spare his time and uh, the very interesting single slide he has made, and so many things are put up into this in a very systematic manner. And thanks all the participants for joining. Stay tuned. Next month, last Friday, again, we'll be meeting with the new speaker, and it will be again at 4 p.m. Thanks for joining. And
And also thanks to Narayan, who was connected
of course,
seamlessly and invited.
yeah, yeah. He could not join today's session because he's on
Yes,
another
yes, yeah.
assignment. Yeah.
Yeah. Thank you.
Okay.
Thank you.
Yeah. Bye bye.
Thank
Thank you.
you. Thank you.
So participants, stay tuned, and whatever next would be there, we'll send you across email or the other WhatsApp groups and all. Have a great day ahead. Bye bye.
Thank you.
Thank
Have a
you.
nice day. Bye bye.